This is Unit 8, Module 3, Similar Solids video. So what are similar solids? Similar solids have the same shape, but not the same size. So there's the same shape, but not the same size. Two solids are similar if the ratio of their corresponding linear measurements are equal. Linear measurements meaning height, width, and length. Those are our linear measurements that we're talking about. Oh, I guess we could put that there. Height, width, length, slant height, perimeter, radius, diameter, circumference. Radius, diameter, circumference. So looking at our examples, let's look at number 1, 2, and 3. So we have to see if all their sides have the same ratio. So you have to compare corresponding parts. So if we look, here's our height, and there's the height. It's going to be 12 and 3. So if we set up our ratio, I'm going to say big to little. So I'm going to say 12 over 3. Is that the same as my sides? So it's still big. So it's 8 over 2. Big on top, little on bottom. And then we're looking at our sides. 20 over 5. All of those have to reduce to the same ratio. Well, 12 over 3 reduces to 4 over 1. 8 over 2 reduces to 4 over 1. 20 over 5 reduces to 4 over 1. So yes, they are similar, and it says give your scale factor. Your scale factor is 4 to 1. If we look at number 2, so we're comparing our same sides. So this time we'll go little to big because we're just working left to right. So we have 6 over 10. Then we have 6 over 10 again. And then we're looking at the height, 8 over 12. So we have 6 over 10, which is going to be the same, but is that the same as 8 over 12? So it reduces to 3 over 5, 3 over 5. And that's going to reduce to 2/3. So these are not the same. Looking at our last one, number 3. If we have, this one gives us our radius, so on this one we'll find our radius. And then it gives us the height, and we'll have the height. So if we go big to little, on this one our radius is equal to 12, so we'll do 12 over 10. Then we have 30 over 25. So this one reduces to 6 over 5. This one reduces to 6 over 5. So yes, this one does too, and our scale factor is 6 to 5. Okay, so that's how we tell if they are similar. So now, if we know that they're similar, we can compare the volume and surface area. So if two solids are similar with the scale factor of A to B, then their volume and surface area ratios are as follows. Your surface area would be A squared to B squared, and your volume is A cubed to B cubed. Okay, so you just take whatever your scale factor is, and you would either square it for area or cube it for volume. So looking at number 4, it says identify your scale factor ratios for each pair of similar solids. So let's start with, it already tells us that they're similar. So to cut some corners, we're just going to take their heights. I'll say big to little, so it's 6 over 3. So my scale factor is 2 over 1. So my scale factor is 2 to 1. So starting at your scale factor, you have to do the surface area. So we're going to, remember that's A squared to B squared. So 2 squared is 4. 1 squared is 1. Then starting at your scale factor, then you come down and you do the volume, and now it's going to be cubed. So 2 cubed is going to be 8. 1 cubed is 1. So once you get those, let's turn to the back. So you can do number 5 on your own, but let's look at number 6, because when given our surface area volume, you always find the scale factor AB first. So if you're trying to find your volume, you have to go back to the scale factor first. So if we look, they gave us our surface area of 25 and 4. So if we write that the surface area, it's 25 to 4. You have to take your square roots to get to what your scale factor is. So square root of 25 is 5, square root of 4 is 2. So my scale factor is 4 to 2. They told us that our surface area ratio was 25 to 4. So starting here, you had to go back to your scale factor. Now you have to go down to the volume. So now it'd be cubed. So 5 cubed is 125. 2 cubed would be 8. So now when we're looking at number 7, they gave us our volume, 162 to 384. So when we write it, 162 over 384, first you want to make sure that it doesn't reduce. So we'll do 162 over 384. It reduces to 27 over 64. We have 27 over 64. Then because it's the volume, so our volume ratio is 27 to 64. First we have to go back to our scale factor. So because it's volume, instead of taking the square root, you have to take the cubed root. You need to remember on your calculator, I use the button between the 9 and the book. Pick that guy, turns 3 on the outside, and 27, so you get 3. And when you do that for 64, the cubed root of 64, you get that it is 4. So your scale factor is 3 to 4. Now you can go back and do your surface area. So you would square it, so it would be 9 to 16. Okay, so let's look at 2 more, because if they give it to us in a word problem, sometimes we have issues with that. So let's look at 9 and 12. So solid A is similar to solid B. The ratio of the height of solid A to the height of solid B is 7 to 3. So they give you the regular ratio because height is one of your measurements. That is your scale factor. So your scale factor is 7 to 3. They ask you for the ratio of your volume. So you're going to end up cubing it. So 7 cubed. Here, let's work it out. So they give you the AB. So if you get the volume, you're going to be cubing it. So when you cube the numbers, you get that it's 343 to 27. Okay. So then let's look at number 12. Pyramid A and Pyramid B are similar. Pyramid A has a volume of 648 meters cubed and Pyramid B has a volume of 1029 meters cubed. What's the ratio of the surface area of Pyramid A to Pyramid B? So they give you A cubed, B cubed. So that is 216 to, actually what we need to do first, let's set it up so it's 648. Yes, ma'am. Okay, so before we get to 216, we need to do 648 over 1029. We need to simplify. We need to make sure it doesn't reduce any. So if we do 648 divided by 1029, that reduces to 216 over 343. So our volume ratio would be 216 to 343. It wants surface area, but remember when you have the volume, you have to go back to your scale factor. So when you do that, you have to take, our next step would be, we have to take the cubed root. Okay, that's our first step. So if you take the cubed root to get back, The cubed root of 216 is going to be 6. And our cubed root of 343 is going to be 7. From there, then, we can find the surface area, scale factor, by squaring our numbers. So we get 36 to 49.